All right. Hey, party people. So in today's class, we figured out how we can get some party hats going, the amount of square inches of all those cones, multiplying them up. And your homework or part of your homework is going to get to in class is number 4 right here, where we're not talking about party hats. We're talking about the good old ice cream that we might have at the birthday party. And we got Lakili here, and what he needs to figure out, let's maybe underline it real quick, is to get the volume of the ice cream. Okay, I got my volume formula for the cone, right? The amount of cubic inches we can fit in that cone. And he also needs to find the area of that cone. Now, that cone, it'll just be the lateral area because that cone is hollow, right? It's hollow. An ice cream cone, right, is not going to include the base. It's open so that we can stick that beautiful ice cream there inside of the cone. Okay, so we got the lateral area formula. We got the volume formula. And what else are we given? Well, let me change colors here. We are given the diameter of the base of the cone is 4 inches. And I see that there, right? 4 inches. And if you remember here, diameter equals twice the radius. And that's important because I see radius in my lateral area formula for a cone, pi RL, and I see radius squared in my volume formula for the volume of a cone, 1/3 pi r squared h, okay? So if my diameter is 4 inches, my radius is simply going to be half of that, okay? Because 2 times 2 would get me to 4, okay? So my radius here is going to be 2, and that's what I'm going to put into that part of my formula. Oops, that part, just the R part, and then I'm going to plug into the R part of my R squared for the volume formula. What else am I given? Oh, I'm given the slant height. Yes. Okay, so this is going to be the distance from the apex of the cone down to the edge of the circumference, really, of the base. Okay, it's not the height of the pyramid, of the cone. We're going to get to that later. So it's not H. No. It's not H. The slant height is L. That's right, slant height here. Wait, I need a different color. Let's go orange. All right, L. So what I'm given there, slant height is 6 inches. So I'm going to need to deduce my height. I'm going to do that later. Use the Pythagorean theorem. Okay, so L is 6 inches. And that makes applying this formula very easily. So why don't we just knock that guy out real quick. My area here, lateral area of that cone, is going to be what I have here. Look, L is 6. R is 2, and then I have pi. Okay, so I'll do pi. Can't have ice cream without pi. Pi times by 2, because that's the radius, times by L, right? Pi RL, pi RL, pi RL. And I'm going to multiply by 6, and then I'm going to simply just get 12 pi. Okay, so I have 12 pi, and this is in inches. Okay, so I'm going to have my lateral area. That's going to be square inch. Oh, pi. Sorry, pi. Can't forget the pi. Right, there we go. There's a little pi. Oh, that symbol's really ugly. Let me write a more elegant pi right there. 12 pi square inches. And if I wanted to get an exact answer for my lateral area, and I might want to if I'm like interacting with, whoever my maker of the cones are, because I'm ordering a lot of them or something like that, I would just do 12 times by little pi symbol. There you go. Okay, so approximately 37.7 square inches of lateral surface area of that cone. Okay, so that was the easy part. That probably isn't why you're watching this video. You're probably watching this video for the volume part, because the volume part will be 1/3 of the equivalent volume of a cylinder that would have the same base area and the same height. Okay, so I have the same base area. I'm going to know because I'm going to take pi and multiply it to R squared, and R again is 2. Okay, so I'll do pi instead. I want to stay very organized in math. 2, and then square it. And the question is, what is H going to be? And let's change colors here to maybe purple to start talking about H, okay? H is up here. Look it out here. This is the distance, right, from a point, the apex, to a plane. The shortest distance to that plane would be the altitude, right? So it would be the height. So that would be right here, okay? I got to figure that out. Well, what do I know about this cone? My lateral surface is 6 inches. Okay, my lateral edge, or lateral, sorry, slant height, right? Slant height here is 6 inches. Slant height here would be 6 inches. So my altitude, okay, would be actually running down through an isosceles triangle, this cross section of the cone cut vertically like this here through the apex would be a triangle, an isosceles triangle, because my slant height is 6 here, slant height 6 here. So if I drop a perpendicular, it's actually going to bisect the diameter of the cone, okay? And then so that means that this forms a triangle here with the height and the slant height and the radius, okay? My radius here is going to be 2 inches. So basically, to get the height of this, which is I'm going to plug into there eventually, okay, is that my height is a leg in a right triangle with a hypotenuse of 6, because that's the slant height, 6 squared, okay? And then my other leg is going to be the radius of the base, okay? So I'll do 6 squared minus, so c squared minus a squared. And I'm going to have to take the square root here. So right, I'm trying to save me a little bit of time doing the Pythagorean theorem, okay? If I want to get a leg, I just square the hypotenuse and subtract the square of the other leg, and then I had to take the square root, right? We've been doing that for months, okay? So I do 6 squared minus 2 squared is going to give me the height. Allow me to deduce it using the Pythagorean theorem, okay? 6 squared is 36. 2 squared is 4, so I got to do the square root of 32. And that's nice, because 32, you know what I know goes into 32 is 16. 16 times by 2 is equivalent to 32. And what's nice about 16? 16 is 4 squared. So I can take the square root of 16. Can't take the square root of 2 without approximating it. So square root of 2 is an irrational number, right? I'm just going to leave that as square root of 2. But I can take the square root of 16. The square root of 16 is 4. So square root of 32 is equivalent to 4 times by the square root of 2. If you follow that through line, you got it, okay? So that is my height. I'm going to go ahead and plug that on in, the 4 root 2 in for the height, and I can just plug on into that formula, 1/3 pi r squared h, and mathematically, I will determine the volume of that cone. Let's check it out here. I got 1/3. I'll just leave it as 1/3. Remember, stay organized. Right? We stay organized with math. 2 squared is 4. Okay, I got another 4 there. I'm going to have to multiply to that. Okay, 4 times 4 is what? 16. Oh, man, math is sweet. So let's see here. Pi is still going to be there. I'm doing my pi afterwards. Okay, pi, 4 times 4 is 16. Now I have times by 16 root 2. And yeah, I mean, 16 divided by 3, so 3 isn't going to 16, so it gets a little bit ugly. Okay, so I would leave this personally as, what am I going to do? I'm going to do, multiply the 16 to pi maybe now. So I'll do 16 pi, and then that's all times to the root 2, and then divided by 3 at the end. That's really the cleanest you can really write that irrational answer, okay? So what should you maybe do? You should maybe, like we did up here, change it from an irrational number, right, with pi there and the square root of 3. Let's maybe multiply everything out to get an approximate decimal answer, okay? So let's do that now. So 16 times pi, well, maybe do the root 3 part first, because that's easier with the calculator. So I'll take the 3, take the square root of that. So the square root of 3 is approximately 1.73. That's that. And I'm going to multiply it times pi, which is a button on my calculator. Boom. Okay, so 1.7 times 3.14 is about 5.44. And now I'm going to multiply to 16. So the numerator of this is, this right here is approximately 87. And I'm just going to divide that by 3. And I'm going to get about 29. And hopefully I got this right. Let me know if I got it wrong. Send me a message if I got it wrong. 29, and then this will be cubic inches. 29 cubic inches. Yeah, sometimes when I'm talking and doing math, I really make mistakes with what I'm actually doing. So please do send me a message if I get it incorrect, okay? And then this is also in cubic inches. All right, thanks for watching there, guys. It's too bad we didn't have time to make sure the groups could complete this in class. But keep asking those amazing questions and keep being curious and figure this stuff out. I will see you guys on Monday for the final lesson of the year. And if somebody wants to present this to the class, presentation problem, yeah, it shouldn't be as long as mine. You can get it down to like a minute and a half and take us through it. Thank you, guys. Have a great weekend. Bye.